section 10.9 is solving for sine of theta. So first what I want to do is I want to look at the cosine and the sine graph. So if we look at the cosine graph, and this is what we worked on yesterday, we labeled between -1 and 1, and then we labeled every 90 degrees. So it's a good review from yesterday. And then we said, okay, if I'm looking at the cosine at 0 starts at 1. So my first point went to 1. At 90, the cosine is 0. 180, it's -1. 270 is 0. And 360 is up at 1. So if I just look between 0 and 360, that's what my curve looks like. Well, today what we want to do is say, okay, if I'm just going to kind of look at part of my circle, and say just between 0 and 180, how many solutions could we have? If we're looking at the cosine, you're always going to get one solution. Okay, so there's always one solution when you are looking between 0 and 180 in the cosine. Okay, so let's see what happens if we look at the sine graph. The sine graph then, again, up at 1 and down to -1, labeling it every 90 degrees. Okay, and then the sine at 0 started at 0. Sine at 90 started at 1. Sine at 180 was 0. Sine at 270 was -1. And 360 was back at 0. So the sine graph looked like this. Now if I take that same idea and say, okay, today we just want to look between 0 and 180, now I can see if I'm looking anywhere up here for any positive answers, my graph, okay, I'm actually going to have two different solutions here. Okay, so if I'm looking between 0 and 180, the sine has two solutions. And that should make sense. If you're thinking about your unit circle, there are two places between 0 and 180 where the sine is the square root of 2 over 2. Okay, so the sine is going to be equal to that at both 45 and 135. Okay, so that's kind of what we're talking about here. And this is a formal theorem. Okay, and this theorem says that the sine of theta is equal to the sine of 180 minus theta. So it's kind of what we were just talking about before. So for example, the sine of 45 is equal to the sine of 180 minus 45, which gives you 135. And you know that that's true if you look on your unit circle. Okay, we could do the same thing with the sine of 30. It's the same thing as the sine of, you got it, 150. Okay, they add to 180. Same thing, sine of 60 is the same thing as sine of 120. Okay, because those are those similar angles. So that's all we're talking about today. So here's some examples. So if I know the sine of theta is perhaps a decimal that's not on our unit circle, 0.624, find the values between 0 and 180. Okay, well if I just wanted to find theta, hopefully you would remember that we would do the sine inverse here of 0.624. If I do that, I'm going to get 38.6 degrees. Okay, now the only tricky part is there's two answers between 0 and 180 that makes that true. Okay, so this makes it two answers because we're dealing with the sine. Okay, so to get the other one, I'm going to say, okay, the other one is going to be 180 minus that answer. So 180 minus 38.6 is 141.4 degrees. Okay, so I have two answers, 38.6 and 141.4. Okay, so that's kind of the tricky part. When you are taking the sine inverse, okay, there's going to be two angles that give you that answer. So you have to do that and 180 minus that. Okay, if I look at example D down here, I have cosine of theta equals 0.58. Find the values. Okay, so this time I would do cosine inverse of 0.58. If I do that, that's going to give me 54.55 degrees. Okay, there is only one solution because this is the cosine. Okay, so look carefully. Cosine, there was only one answer. Okay, so you are not doing 180 minus that, so be really careful there. Okay, example E says sine of 42 equals sine of what? Okay, so that's just my theorem here. That says 180 minus 42. So that would give me an answer of 138. Okay, so if you're going sine to sine, you're going to do 180 minus theta. But in example F, when we're going from sine to cosine here, that's what we were dealing with a while ago in the first part of chapter 10, where we did 90 minus that. Those were complementary. So that answer is 72. Okay, so careful. Sine to sine is 180. Sine to cosine, it adds up to 90. Okay, so let's take a look at some of our story problems here. So in triangle ABC, oh, back to triangles. You're so excited. So I've got A, B, C. Little a is 6.5. So little a, if you remember, goes across from big angle A. So that would make this one 6.5. Little c would be across from side C. So that would make this part 10. And the measure of angle A is 35 degrees. And I want to find the measure of angle C. So this is exactly the first part of chapter 10, which is why they're related. So if I look, I have two angles here, which means I'm going to use the law of sines. So you're going to find your pairs here. So my first pair would be these two are matched up. So I could go ahead and say the sine of 35 over 6.5, remembering that you always do sine of the angle over the length of the side. And my other pair would be that angle matched up with side length 10. So hopefully remember from here you're going to cross multiply. So I'd get 10 times the sine of 35 equals 6.5 times the sine of theta. I'm solving for theta, so the next thing I would do is divide by 6.5. So that would give me 0.88 equals the sine of theta. And to get theta, we would take the sine inverse of 0.88 to give me theta. So my final answer is 61.94 degrees. Okay, so that's good. But today we're realizing that if I need this to be true, I could also have two answers. So my secondary answer would be 180 minus that answer. So 180 minus 61.44 is 118.06 degrees. Okay, now what you have to do is make sure, okay, that your secondary angle would work in here. Okay, so if I have 118.06, which is an obtuse angle, which means it's greater than 90, would that triangle still be possible? So what I want to do is see if the angle they gave me is greater than 180, okay, because all three have to add up to 180, so 2 cannot be more than that already. It does not make it more than 80, so these are both possible solutions. Okay, so 61.94 or 118.06. What that means is one of those angles would be an acute, one would be obtuse, so our triangle would just be looking different than we have it drawn here. Okay, and example E, so we'll try another one. So now we've got triangle SPX. S is 75, and S side S across from angle S is 11. X is 9, so that's across from angle X, and I want to find angle X. So set up similar to the last one. So I can say the sine of my angle 75 over the side 11 will be equal to sine of the angle over the side across from that 9. So I can cross multiply. 9 times the sine of 75 equals 11 times the sine of theta. So again, I would divide by 11 here. So I'd get 0.79 equals the sine of theta. To get theta, I would take the inverse. So I get sine of theta to equal 52.21. Again, because I'm taking the sine inverse, because there's two different options, I need to have two different answers. And that second option would say 180 minus your solution. So that would give me 127.8 degrees. Okay, so now let's check to see if that works. If this angle is 127.8 and they gave me 75, this is already over 180. So that solution does not work because these two angles, okay, would be greater than 180, so I couldn't have a third angle. So our only answer is 52.21. So what you're going to want to do is show me that you found the other one and then cross it off because it's not possible and circle the one that does work. Okay, so if you've got questions, write them down and we'll talk about this tomorrow.